As we continue to learn more about the usage of JavaScript in browsers, I want to delve a little bit deeper into the internals of JavaScript itself. Now again, this is some stuff you might have encountered if you've learned JavaScript in a previous class, but I think it's important to examine the underworkings of this and make sure that everyone has a good foundational structure before we move deeper. So to begin with, let's talk a little bit about data types. Primitive or basic question we want here is, does JavaScript even have data types? Do we use data types when we declare variables? And at this point, you should already know we don't. We just type var, or we have an alternative, let, but we basically just declare a variable and we don't worry about what type it is. But does that mean it doesn't have types at all? Well, no. It does have types. The types, however, are implicit. They are implied by the way you use it. When you assign a value to that variable, it looks at the value, and then it figures out what type to use based on that. So it's all done automatically. This is often referred to as loosely typed, or simply as weakly typed. This is in comparison to strongly typed. So more traditional, in fact usually older languages are strongly typed versus scripting languages or languages that are meant to be interpreted are often weakly typed. The two big comparisons here, we usually say that C or Java or C++ are all strongly typed languages where you have to declare the type when you use it, and types are continuously checked to make sure you don't accidentally mix them. JavaScript, on the other hand, is usually considered weakly typed, or at least loosely typed. Types are not declared. They are determined automatically, and while they are occasionally checked, most of the time it simply coerces one type into another. It forces one type to become another so that you can do anything you want to do. And it doesn't check to make sure you aren't accidentally mixing types. That doesn't mean you are free to mix them. Types should still be kept fairly strictly segregated, but it's up to you to do it. The language isn't going to do it for you. Now, specifically, what we have in a language like JavaScript is dynamic type checking. Most other languages that are strongly typed use what's called static type checking. They check the types at the beginning when they're compiling the language and not at runtime. The language will simply refuse to compile if the types are not compatible. JavaScript is not compiled, it's interpreted. So it checks the types at runtime. And it also just tries to coerce those types from one to another. It doesn't even necessarily throw errors when the types don't match. It does still have types, and we need to talk about those types and indicate how we would work with them. So just like in any other language, there are primitive data types that we can work with. In other languages, you might have encountered types like Boolean and integer and float and double. There are similar things. These are the simplest things that you can declare in the language. In JavaScript, we do still have a Boolean. A Boolean is used for things that can be true or false. We have just a number, and a number can represent anything, integers or floating point values. Then we have string. Normally, string is not a primitive data type in a language. It is a object, but in JavaScript, it is a primitive type. These are our three basic primitive types, and they're used to store information that you should already be more or less familiar with. Boolean is going to store true or false. Sometimes it's 0, 1, but it's always just two values. It is a binary system. Number is, well, a number. It can be an integer or it could be something with a decimal. JavaScript doesn't really distinguish between the two explicitly. Now, underneath the hood, it might actually be doing some things. If it recognizes what you're doing is a whole number and just an integer, it will try and store it as such. But as soon as you exceed the ability to do that, it will switch to using a floating point representation, aka just a decimal value. And lastly, we have a string type, which is used to represent text. And really the best way I think of considering a string is that it's used to represent everything on your keyboard and also the keyboards of anyone in the world. It stores characters. And it's ultimately a very simple primitive type inside of JavaScript. We'll look more at how to actually manipulate strings later on. Just because you don't declare it with a type doesn't mean you never need to know what the types are, and there are ways to deal with this. We have an operator called typeOf that we can use to actually look at the type of a particular variable. We also have ways to convert between types if it's wound up being one you don't want, or you want to make certain it is a particular one. And With JavaScript, but really with all languages, you always want to be careful about coercion. Now, coercion is when the interpreter or the compiler actually tries to force your value to be a certain type. And usually when you get in trouble, it's doing that when you didn't intend for it to do it. I think this will all make a lot more sense if we just dive in and take a look at some of this stuff. So, as with other videos here, I have set up a basic project. This is based on that same local server project, so you might want to get that set up for yourself. All I've done on the HTML side of things is just fill in all the titles and such, and then right down here I'm linking in a typical JavaScript file, index.js. Index.js does not do anything yet, but we're going to build some things into it. My intention here is just to use this to explore JavaScript, so everything's going to be written out to the console. And that's exactly why I say in the page, see JavaScript console for info. We're not going to really do anything in the page itself. To play with this, I want to just declare some variables and then run some comparisons between them. And I already have a lot of this set up. I'm just going to bring it over a little bit at a time so we can explore it together. So, let's declare some variables. Here we have several different simple variables that we are declaring. These variables are just arbitrarily named, and in each case I'm trying to assign it a certain type of value in order to force it to be one of those primitive types. The first two here, A and B, are very clearly Booleans. True and false are the Boolean values. Notice you write them without quotes around them. Should already be used to that by now, and these are the Boolean values, and there's nothing else that can really be a Boolean. Here on the second line, I'm doing some numbers. I have an integer. Here I have technically a floating point value or a fractional value. And then I have a value in scientific notation. If you didn't know, you can do scientific notation here. These will all be numbers. And then lastly, I have some strings. And I have really three different ways that I can declare strings in JavaScript. We've seen the double quotes notation, single quotes, which is essentially equivalent, and then this special backtick notation that we call string templates, which really is a little more advanced than declaring just a basic string, but it does work. You can see here this is going to be a string. So these are all different ways to declare strings. The real question is, how can I be certain that it is that? Well, this is where that type of operator comes into play. I'm going to go ahead and pull over a whole bunch of console statements here that we can look at. So what are we doing here? I'm printing out, first of all, just some headers to keep all of our outputs separated a little bit. And then for each of these, I'm going to go through and just use the type of operator right in line. I'm going to say type of A. And what this should do is return the type of the variable A that I declared up here. And as the header says, we expect it to return the word Boolean. So this should print out A is A, and then it will evaluate what's between the curly braces and the dollar sign here. Boolean. I should expect the same thing down here for these. C, D, and E are all numbers, and then F, G, and H are all strings. So let's go ahead and save this and see what we get. So you can see here it does the auto refresh, and immediately for our first two, A and B, I expected Boolean, I got Boolean. For C, D, and E, I expect number, I got number. And for F, G, and H, I expected string, I got string. These are our three basic primitive types that behave the way you'd really expect them to. And it is a little odd that string is a type, but it is. Is a primitive type, but it is. If you've worked in higher level languages, it's something you'll just sort of have to get used to. That doesn't mean it won't be able to do the things that we can do with object-based strings in other languages, but it is technically considered a primitive type when we're working in JavaScript. So this helps us sort of keep track of things. It allows us to be aware of what's going on. Occasionally when we run afoul of types, we have to be really careful, and this type of operator can come in handy. But it's not the only way we can do things. We can also convert between various types. For that, we have specific functions. You can use capital N number as a function and pass it a value, and it will attempt to turn that value into a number. Now, it won't always work. Maybe the value is a string, and some strings, unless they contain just digits, just can't be turned into a number. And it will return specific values in that case. Now, in addition, there's all sorts of little tricks and tips on working with types. These are all specifically things that are designed into the language to try and make it easier to work with these things. And I've got a whole bunch of them here that I want to talk about. First, there's two types of comparisons for equality. There's the usual double equals, which you have available to you in most other languages. And this just checks if the things on the left and right side are equal, and it returns true or false. But there's also a triple equals. This is what's called strict equality. When we do triple equals, we're really asking the question, not just are they equal, but also are they the same type? So when we use triple equals, we're checking both the values and the type. And if the types don't match, it will return false, even if they are the same quote-unquote value. You'll see what I mean by that with some examples here in just a moment. There's also a third thing that's really useful here. There's a function, is NaN. Now, what is NaN? Well, that is an acronym for not a number. Not a number is just a concept for some value that really can't be expressed as a number. So if it isn't an integer or a decimal in some way, is not a number will return true. And that can be very useful. Well, you'll also find that the idea of not a number is in fact a numerical value that is representable as a number type. That's really the purpose it serves. If you try and convert something to a number, like right down here, and it's not actually a number, the value it returns will be NaN. And that is actually technically a number. So it serves that purpose of you gave me something, asked me to turn it into a number, and I couldn't. The long and the short of is NaN, that will be something that will be very useful for testing if something is a number or not. That's generally how we'll go into it. There are also some special cases. If you try and take an integer and divide it by 0, you'll get back something that also tests true for not a number. As you may know from math classes, dividing by 0 does weird things. And so when we're dealing with that in computations, we often need to be able to test that the result did divide by 0, especially if variables are involved. Now, some other things that are really useful. We can definitely tell if something is a number or not by doing the following. We take it and we test whether or not it is equal to itself as a number. If this returns false, that definitely means whatever we got back when we tried to convert it to a number wasn't really true. This is one of the more efficient ways to actually test if something is truly a number or not. And it's a little more predictable than the whole is_nan function. You also, again, encouraging that you make use of what are called the type objects. We've already seen one of them, number with a capital N, and we're going to see more about string with a capital S later on. And there's also one for Boolean with a capital B. These all have little functions built into them that you can use to convert things to those types, but also, particularly for string, it allows you to do all sorts of special things with a string, and those are important to know about. Lastly, we have a couple special things, null and undefined. These are things that pop up in a lot of different languages, or at least null does. And undefined is an even more useful thing, especially once we start getting into objects. Again, this is something that the difference between them is fairly subtle. Null is something that has intentionally not been given a value. So you could set a particular variable equal to null, and that basically says, I didn't want to give this a value yet. I'm leaving it null. However, we have another idea. Undefined is something that has never had a value. You didn't set it to anything. You declared the variable, but you didn't define it. And that's subtly different from null. Null, you deliberately left it undefined. You assigned it null. But undefined, you've never defined it as anything. When we're dealing with objects, it's going to be important to know the difference between the two, between something that you deliberately defined and something that you've never even talked about at all. Let's go back again to the example and take a look at all of these things. Again, I think all of this makes more sense when we put it into practice. So here we played around with a type of operator, and you see how you can use that to deal with things that are of primitive types. I will note it also works for a couple other types, namely arrays and objects. But we're going to take a look at those at a later time, so we won't really worry about it at the moment. Let's go ahead and look at the difference between double equals and triple equals, and what I call the non-strict comparison and strict comparison. So I'm going to bring in over another big chunk of code here to look through. So here we are looking at the double equals sign, which is non-strict comparison. It will allow things to be equal if their values are equal, even if they're not the same type. So here we compare 5 with 5. It doesn't get much more equal than that. This should return true. Here we're comparing the number 5 with the string containing the digit 5. If these two things had been compared in a more strict way, we'd say no, one's a string, one's a number. But here JavaScript is going to coerce the two into a similar type and then compare them. So it will use coercion, and it should come back that yes, these are the same thing. And we as human beings look at them and we think, oh yeah, 5 is 5, that makes sense. Now when we start dealing with booleans, this gets a little more complicated. True itself is a boolean value, and it turns out it's equal to 1. We do allow numerical representations of booleans. So 1, at least if you compare it in a non-strict way, is the same as true. But other values are not. 100 is not. And interestingly, the string containing the word true is absolutely not the same as the value true. We'll see there's a similar concept with false. 0 is the same as false. -0, which is a thing, is the same as false as well. But the string false is not the same. Let's save this and sort of see all of this in action. So 5 equals 5, that's true. The number 5 equals the string 5, that's also true, as long as we're using double equals. And now let's look at comparisons with true. It is the same as 1, as long as you're using non-strict equality. But it's not the same as 100, and it's not the same as the string true. So watch out for that. This is one that often catches people with problems. Though I imagine we won't get into any programming that involves strings with the word true or false in them. Still, it's one to keep in the back of your mind. False is the same as 0. It's also the same as -0, but it does not evaluate to be the same as the word false. Now let's take a look at the alternative, the triple equals, or strict comparison. Generally speaking, we expect this to be a subset of double equals. It's going to be more strict about these things, so fewer things will be identified as the same by the strict equals, and that is definitely true. Oh, there's a mistake in here. This should be triple equals here. Let's put that in there. So let's see what happens with this. 5 triple equals 5. They're both numbers. They both have the same value. That comes back as true. But 5 triple equals the string 5 comes back as false. Remember, when we used double equals, it came back as true, but here it comes back as false. So they are not the same type, therefore it's going to tell us it's false. Now here we have the same comparisons between true and 3 things and false and 3 things, and you'll notice they are all false. And that's because the things on the right side of these equations aren't booleans. One's a string, the other 2 are numbers. And it will always say false if they aren't the same type. That's really all strict comparison gets you over non-strict comparison, is that if they aren't the same type, it will say false. Let's take a look now. We've looked through non-strict comparison and strict comparison. Let's look at what we can do with these type conversion. So I mentioned here that we have this sort of function, a capital N number, that will take whatever value you give it and try to convert it to a number. To examine this, we can use this as a way to basically determine if a variable is a number or not. That's a little more useful than if we work with this whole NaN concept. So here we have this. We're going to declare, I do this with a variable because that's a little more typical that you would do this with a variable. We have variable 1 input, and we set it to the string 25. And then we have variable 2, input 2, that we set to the string ABC. This is very typical of what you might get from someone typing into a text box. You're always going to get a string back from that, even if it happened to be a string of digits. Now, a string of digits is a number, but you're going to get it back as a string first, and so you want to be a little bit careful to test it and make sure what they gave you is what you expect. So here's what we're going to do. We're going to set up the equation. Is the variable equal to number, the number function applied to that variable? If these two are the same thing after it's been converted to a number, it's still considered equal, well, then it was successfully converted, we're going to say. Now note, we use non-strict equality here, and that's important. And just to send that home, we're going to use strict equality down here just to see what we get. So we're going to try this first with 25, then with ABC, and then again with the strict equality. Let's see what we get. So here we go. The first one, when we say 25 equals number 25, that returns true. And basically, this was a test that said input is a number. We say input equals number input. That says yes. If it returns true, that means that input is a number. The value of input is a number. Here, we try ABC equals number ABC, and well, we get the result false. It is not. Here we try 25 triple equals number 25. So the only difference between this one and this one is that we're using strict equality. Here we get false. And the reason is the thing on the left is a string, the thing on the right is a number. And strict equality will always return false in that case. So this is the key idea here. If you take a variable like input and ask, am I equal to number input? If that comes back true, it is a number. If it comes back false, it is not. Let's just look here real quick. I'm going to type in right to the console, number ABC. And let's see exactly what it returns from that. There we go. We tried to convert a string that does not contain digits into a number, and it returns back NaN, not a number. So we see there exactly how NaN works. What it's returning back technically is a value that could be stored in a number, but it's one specifically designed to indicate something is not a number, NaN. Now let's keep moving along here. We'll talk more about null and undefined here. Well, why don't we go ahead? Let's talk a little bit more now about null and undefined and what they are. Null generally exists in every single computer language that you're going to use, and it usually means the absence of a value. You've declared it. It's a variable. It's out there, but it hasn't been given any value yet. And so this is something very specific. JavaScript also has the concept of something called undefined, and that's a little more complicated. I'm going to bring over a whole bunch of stuff here. Actually, let's just bring over the first batch. We're going to compare undefined null and then this thing we just saw, nan, N-A-N, and see how they all compare with one another. So let's bring this in down here, and first see what of these three things is actually undefined. So first, is undefined. Does that equal undefined? And notice right here the variable is undefined. I've declared it, but I haven't said it's equal to anything. I'm just declaring it. And so we should hope that it will say yes, it is undefined. And we're going to test it both with the non-strict equality and the strict equality. Then we have another variable, is null. Is null has been specifically set equal to null with a lowercase n, which is the constant, null, which is a value. And we're going to ask the question again, is it undefined? And is it strictly undefined? So first non-strictly and then strictly. Let's see what that all gives us back. So we can see here the first three all evaluate to true. Is undefined undefined? Yes, it is. Is it strictly undefined? Yes, it is. It's undefined. That's what it is. Is null undefined? Well, if we're asking it in a non-strict way, it says, yeah, sure, null is undefined. But it's because we asked non-strictly. If we ask strictly, it says no. Strictly, these two are not the same. That's the conceptual idea. Now, why is that? Well, it turns out that null is more than just a value. It is a primitive type. And so is undefined. It is also a primitive type. And they do that specifically so that this makes sense. If you tried to compare these two, they'd still give you false if you use strict inequality. Let's do the same thing, but let's compare it with null instead. So let's bring that over here and look at those values. So here, we're taking the same four values, but this time we're comparing them with null, both with non-strict and strict equality. So these are the four new values here. So is undefined null? Well, if we're comparing non-strictly, it says yes, it is. But if we're comparing strictly, no, it's not. The same way these two were right here. This is really just reversing these two. And then here, if we ask, is it equal to null? True. Is it strictly equal to null? Also true. So again, you can mix undefined and null if you're using non-strict equality. with the understanding that you won't be able to distinguish between the two. But very often that's exactly what you want. If you're using strict equality, mixing the two will often result in a false statement. So keep that in mind. You can distinguish between the two of them if you use strict inequality. And that's usually exactly what strict inequality is for. Now let's throw nan into the mix and see what happens with it. I'm going to pull in 3 comparisons here. So I have 3 variables, is undefined, is null, and nan value. So is undefined is, as we know, undefined. Is null has been specifically set to be null. Nan value we're setting to this constant, capital N, lowercase a, capital N, which is a thing, just like null is. And when we set it to that, it's basically a variable that's been set equal to nan. Here, we're going to use non-strict equality to compare all 3 of these. So if we save this and run it, let's see what it says. All right, so is undefined equal to nan? It says no. And keep in mind, that was non-strict, and it still says no. Is null equal to nan? Non-strict. Still says no, it's not equal. Well, is nan equal to nan? It still says no. This is a special case. Nan, not a number, is hardwired in the language to always return false when you compare it to it, even if you compare it to itself. Let's throw one other one in here just to drive this home. Right here, if we say nan equal to nan, even in non-strict, which should be more forgiving, let's see exactly what happens. It says false. That should feel weird. Does nan equal nan? False. This is something that is hard-coded into the language because it ends up being useful. We want to, if anytime a number comes back as being nan, if we can simply compare it to itself, and we will find out that it is nan because it returns false. Pretty much all languages behave this way with nan. So what does that mean? Well, it means you shouldn't be comparing them with equals if you truly want to know whether it's nan or not. And that's why I pointed out there's a function specifically for this, is nan. If you want to know if something is nan, you need to actually use that function. So let's bring this back over here. We're going to try this instead. We're going to take those 3 variables and we're going to pass them into the is nan function. So the undefined one, the null one, and the nan value. The expectation is that undefined is not nan, so it should return false. Null is also not nan, so it should return false. And nan is nan, so it should return true. Let's see what we get. And here's what we're getting. Undefined comes back as true. Undefined is apparently the same as nan. Now, why is that? Well, that's just how it's defined. I don't know exactly what the reasoning is behind that. But if you haven't given something a number, then we say, yeah, it's not a number. Now here, null, if I give null to is nan, it comes back and says false. Because technically null, well, it is a number. It is a numerical value. But if I give nan to is nan, it comes back again as true. And that should be expected. So these behave a little more predictably and are generally preferred over using equals of any kind. I really put this out here just to demonstrate one thing. Nan and null and undefined are a very complicated world. By and large, undefined and null are the ones we will use more than anything. And unless you're getting really down and detailed, you probably don't want to venture into the world of nan. I show all of this for completeness so that you have the theoretical foundation of how all of this is supposed to work together. In this class, we might occasionally test if something is null. We might occasionally test if something is undefined. And we'll do it exactly like we did here. We'll say double equals undefined, or we'll say double equals null. And occasionally we might go for the triple equals if we really want to distinguish between the two. But most of the time, a simple non-strict comparison with either null or undefined is all we really need to get the job done. All these other ones have subtle differences between them, and you can examine these if you ever need to, and if you want to make sure that the results will be predictable. And that's exactly what I'm doing right here. I'm going through and doing all kinds of examinations of these to make them a little more predictable. So, I'm not expecting you to know the subtle differences between all of these. I won't quiz you on it or test you on it. Do know the broader difference, though, between null and undefined. A null value is one that has been intentionally set up to not have a value. We've assigned it null, and so I've said I meant for this to not have a value. Undefined is one that you haven't assigned anything to. And the name kind of says that, right? If you just go by the name. Undefined means you never bothered to give it a value. One last thing I'd like to take a look at. We have two other data types that are very important. These are not primitive data types. This is where we get into more advanced data types. The first one is an object. You declare objects using curly braces, similar to how you declare a class in things like C++ and Java. But I will warn you, objects in JavaScript are nothing like objects in C++ and Java. You can use them in similar ways, but under the hood, they're very different. And we're going to get into a lot more detail about that later on. We also have arrays, and just like other C-based languages, they're declared with square braces. What you end up with this is not strictly an array in the same sense that it would be in a language like C or C++ or Java. They're more like what we call dynamic arrays, arrays that can grow and shrink over time. And in fact, for those that have had some data structures, if you've heard the term hash map, that's really what they are. They can even store things that aren't based on integers. And again, we'll get into all of that at a later time. Mostly, I wanted to demonstrate to you how we declare these and how we can sort of test whether something is that or not, in the same way that we tested the primitive types up here. These are not primitive types. These are something more advanced. To do this, let's, again, create a couple of objects that are these variables. I'm going to do it down at the bottom here. So I'm going to declare I to be curly braces. What is that? That's an object. I'm going to declare J to be square braces, and that's an array. I'm not putting anything in them at this time, so they're just empty, but we can still take a look at them. Let's go ahead and test these with that same type of operator. This is technically an operator, and see what it gives us back. So we see here it tells us that I is an object. That's good, but it also says that J is an object. That might seem a little strange, but this is basically what it says for anything that's not a primitive type. Anything that aren't primitive types, well, they're objects essentially, and so they are stored internally in that structure and treated that way. So the question becomes, how can I tell if something is an array? Well, we have an extra thing for that. We have this function, array, capital A, dot isArray. You pass in the variable and it will basically return true if it is, false if it isn't. So we expect I to return false, and we expect J to return true. And that's exactly what we get. You can search around on the internet. There are other ways to determine the difference between an object and an array in JavaScript. And some people argue that some are more efficient than others, but it all depends on what particular browser you're using. And really that's what array.isArray is intended to do, and I recommend using that. One last thing I'd like to talk about is sort of a conceptual thing, because it's very likely that your heads are spinning now with all of this information. There's lots to think about when it comes to data types and how they all work together. Ultimately, we can, at the end of the day, ask a very different question. This is a paradigm that's known as duck typing. And as you might guess, it basically asks the question, if it walks like a duck, swims like a duck, and quacks like a duck, it is a duck. That's what we're going to say. This is normally a legal argument. If we're trying to determine whether something was or wasn't a happening, lawyers will often say, look, here's all this evidence that says it is that, therefore we should conclude that it is. In the programming world, we use this slightly differently. We say that what's important about a variable really isn't specifically what it is, but rather how it functions. Does it do the things that a duck does? And if it is, we can treat it like a duck. It really doesn't matter that it isn't a duck. This is generally a maxim when you're working with JavaScript or really any weakly typed languages. Don't worry about what type it is. Just see if you can use it that way. Can I use it as a string? Can I use it as an array? If you can, and it does what you need it to do, the rest doesn't matter. We don't really care what type it is. This is, most JavaScript programmers operate this way. Once we get into working with objects and you see that these types can vary a lot more, this will become a lot more important. But even with primitive types, with all the coercion that's going on under the hood, very often at the end of the day, as long as it operates the way we want, we don't really care whether it was actually a number or a boolean or a string. If it did what we wanted, we're happy. This also means that you need to spend a lot more time testing. You need to test input in particular. Try all the different things that the user might give you and see which one of them causes your code to break. That's when you really need to ask the question, well, maybe they didn't give me a duck when I asked them for a duck. We do still need that fundamental underpinning. Will it behave like a duck? And where that's most important is when you're dealing with numbers. If you ask the user for a number, make sure their input behaves like a number before you try and use it as such. That's about the only time you can go wrong with this. We'll see a lot more about this as we start looking into arrays and objects, where this idea of duck typing becomes more important. For now, I encourage you to play with these things. You build an intuition about this stuff over time. We often think that when we're working in a loosely or weakly typed language, that all of these safeties that we have in place of typing have gone away. That's not the case in JavaScript. It's simply that we aren't being explicit about them. That will occasionally get us in trouble, but as long as we know that types do exist and how to examine them, such as with the type of operator, we can usually salvage what we're doing and find the bug pretty quickly.